So we're talking about the cell, the plasma membrane. Okay, so the plasma membrane is the cell membrane around the cell. It's made up of a phospholipid. This is a phospholipid right here. Okay, can you guys see my mouse moving? Do y'all see the
Yeah.
mouse moving?
Yes.
Yes.
Yeah.
Okay.
Yes, sir.
So where's the mouse now? What's it on?
The head.
The polar head, right? Good. Okay. So this is a phospholipid. It has a polar head and two nonpolar tails. Okay, so this is how cell membranes are built. There's phosphorus in this top portion right here. Okay. So if you put these phospholipids in a liquid, they will arrange themselves in a bilayer. They will arrange themselves in a bilayer. And when a cell is made, we have this model of a membrane. So the purple are proteins. The little tails and blue heads are the phospholipids. Glycoproteins are carbohydrates attached to a protein. Glycolipids are carbohydrates attached to the phospholipids. Okay, we got to let somebody else in. Okay. Okay, so this membrane has cholesterol in it. It has proteins, and it's made up of the phospholipids with the polar heads facing the outside of the cell in the extracellular fluid and the inside of the cell in the cytoplasm. Make sure you know what a glycoprotein is, a glycolipid. Proteins are inserted into the membrane. Proteins can be enzymes. They can be channels that provide pipelines for materials that move in and out of the cell. Integral proteins span the entire membrane. Other proteins, peripheral proteins, are only partially through the cell membrane. So again, let me repeat. Glycoproteins are a carbohydrate chain attached to a protein. Glycolipids are a carbohydrate chain attached to a lipid, a phospholipid. The glycoproteins and the glycolipids are identifiers for cells. It helps tell other cells and hormones what kind of cell is next to them if they're moving around. Protein channels allow substances to move in and out of the cell. Some membrane proteins have binding sites to move substances in and out of the cell. So proteins allow for movement of substances in and out of the cell, and that's one of their main functions. A lot of proteins have a receptor site. A ligand is a compound like insulin or norepinephrine, epinephrine, adrenaline, for instance, that binds to the protein channel, and causes it to open. So often a substance like insulin or thyroid hormone will bind to a channel, a protein channel, and open it up. Some proteins function as enzymes. They speed up chemical reactions without being used up themselves. Some proteins provide structural support. They're part of the cytoskeleton. Okay, somebody else is coming in. Okay, back to PowerPoint. Okay. Sometimes proteins hold cells together. So in your digestive tract, individual epithelial cells will be held together by these linker proteins to make sure they don't leak. Make sure there's no leakage between the cells so that the cells in your gut can control what goes in and out from the lumen, from the stomach contents, from the intestinal contents into the blood around the cells. I mentioned glycolipids and glycoproteins. Here's cholesterol. I said these are carbohydrates that are bound to proteins or phospholipids, and they serve for cell recognition. If you have a drug that stimulates a receptor, that's an agonist. If you have a drug that blocks, that's an antagonist. Everybody knows what an antihistamine is. Okay, so membranes are selectively permeable. They allow some water, oxygen, CO2 to go through, some fatty substances. So we're going to talk about passive transport and active transport. So whether a substance goes through the membrane depends upon its type, how soluble the substance is in the membrane, and the concentration on either side of the membrane. So passive transport is simple diffusion, facilitated diffusion, and osmosis. If I put a colored sugar cube in water, this is the high concentration. Eventually, it will diffuse throughout the whole liquid environment, and that's a concentration gradient. Starts off with high concentration. So we talk about a gradient, meaning that there's more of one substance on one side of the membrane or the other. So diffusion is a passive transport process. It depends upon the moving from a high to a low concentration. The substance will diffuse until it's equally spread throughout the liquid and equilibrium is reached. So oxygen, carbon dioxide, lipids, and hydrocarbons go right through the membrane. Facilitated diffusion means there's a special channel to let substances go from a high concentration to a low concentration. Osmosis is the movement of a high concentration of water to a low concentration of water, or to a low solute. The greens are dissolved, so there's more water on this side. Water will diffuse to dilute this high concentration of solute. Special channels known as aquaporins, particularly in the kidney, they are used and put in membranes to allow water to move in and out of cells. So osmosis moves from a higher number of water molecules to the lower number of molecules. So make sure you know this definition of osmosis. Water will move through a membrane to establish equal concentrations, and that may change the volume of water. When you go get an IV, you get an isotonic IV, meaning its concentration is the same as the blood plasma. So you'll have, since the concentration of water on both sides is the same, the net movement is none. Water moves from left to right or right to left when you have the same concentration on both sides. So if you have an extracellular fluid that has more dissolved materials, so there's more water here, less water per volume. So the water will move from left to right and the cell will shrink. That's called crenation. If you have a higher concentration of water on the outside of the cell, notice there's a high concentration of solute, so the water will move, cause the cell to swell and rupture or lyse. So a summary of this process: you want to get isotonic saline so that your blood vessels, or the blood in your blood vessels don't shrink or burst. Okay, we'll stop there. I'm going to have little chunks recorded, so I'm going to go back to, I got to turn off the recording for a moment. Okay, stop